Hello sir, my name is Bakka Venkata Subbareddy, registration number 19BEC0523, and this is the digital assignment 1. Microprocessing element used for our project are the Philip 80C51 8-bit microcontroller family. So these are the questions, and let's move on to the first question. Draw the clear block diagram of the Philip 80C51 8-bit microcontroller. So this is the 80C51 8-bit microcontroller diagram. And moving on to the B part, give the internal diagram of each and every block of 80C51. So these are the each and every blocks of 80C51, as you can see here. And second question, provide the instruction set of the microprocessing element 80C51 with clock cycle required or a machine cycle required, memory required. So this is the arithmetic instructions, and these are logical instructions, and these are the data movement instructions, bit processing instructions, and program flow control instructions. And moving on to the third question, explain microprocessing element the Philips 80C51 architecture. So this is as you can see here, the description, and these are the features and parametrics, and these are the pin configurations. And coming to the fourth one, correlate the microprocessing element 80C51 architecture with the architectures discussed in module 1 and 2. So this is the microprocessor discussed in module 1, 8085, 8086. Microprocessing element discussed in module 2 is 8051. And here is the correlation between 8085 microprocessor with 80C51 microprocessor. Here is the correlation between 8085 microprocessor with 8086 microprocessor. And moving on to the fifth question, compare the register organization and RAM to ROM memory organization of the processing element 80C51 and module 2, which means 8051. So this is the register organization in 80C51. 80C51 special function registers, and memory organization and programming model of 8051, as you can see here. This is the on-chip memory organization, math registers A and B, and internal RAM, register banks, internal ROM, special features registers, accumulators of A, B, and PSW. And this is the carry flag, auxiliary carry flag, and flag 0, and register RS0 and RS1, overflow flag, and parity flag, and program counter, data pointers, stack pointers, input output port registers, peripheral data registers, and the ninth one is the peripheral control registers. In that we have interrupt priority, time control priority, and serial port control, and power mode control. So moving on to the sixth question, Compare the amount of time required to execute a complex instruction like multiplication, division in all the processing elements, which means 8051, 8085, 8086. For processing elements like 8051, as you can see here, for processing elements 8085, and this is the flowchart explanation of it. And for processing element 8086, using NOT instructions, and here it is using 8-bit register as counter, and using 16-bit register pair as counter. And moving on to the 7th question, find what type of peripheral interfaces available and correlate its performance with the type of peripheral in module 5 in the ECE 3003 syllabus. Peripheral, serial communication and interrupt priority structure of 80C51 as follows, as you can see here. And this is the IE register and the symbol function and IPH register and its symbol function, and module 5 8051 peripheral, serial communication and interrupts in the 8051 are as follows, as you can see here. And moving on to the 8th question, explain the ADC, DAC and sensor with the signal conditioning interface technique available in all the processing elements. Find the advantages of peripheral interfacing management techniques over the concept given in module 7 in the ECE 3003 syllabus. So ADC parameters. So analog to digital converter parameter helps in selecting an ADC device for a particular application, because these parameters will decide the performance of the final product in which ADC is being used. Resolution, the resolution specifies the smallest input voltage change that can be detected by the converter, which means the change in input that causes the digital output to change by 1. So the common ADC chip, the ADC080X series from National Semiconductor, uses successive approximation method for conversion and STTL compatible to be interfaced with microcontrollers or processors. So here is the ADC 0801, 02, 03, 04, 05 chips diagram also you can see here, and DAC parameters and common DAC chips and DAC 0808 chip and its diagram you can see here, and temperature sensor LM35, and this is the basic configuration of LM35 and the full range configuration of LM35. And moving on to the 9th question, provide the instruction set of the microprocessing element, microprocessor or microcontroller or IP core with flag affected type of instruction based on the addressing modes, operations, etc. So this is the arithmetic instructions, and these are the logical instructions, and these are the data movement instructions, and this is the bit processing instruction, and program flow control instructions or call and jumps. And moving on to the last question, draw the control word formats for special function registers of the Intel i3, i5 and i7 series processor and microprocessing element, microprocessor or controller or IP core like IE, IP, PSW, flag register and PCON and SCON and TMOD and TCON. And in 80C51 8-bit microcontroller programmable clock out. So this is the timer 2 operation, and this is the capture mode explanation, and auto reload mode, up or down control counter, and this symbol position name and significance, as you can see here, and diagram for timer 2 in capture mode, and diagram for timer 2 in auto reload mode, TCEN is equal to 0, and this is the diagram for timer 2 auto reload mode, DCEN is equal to 1, and this is the diagram for timer 2 in word rate generator mode. And these are the data sheet for 80C51 8-bit microcontroller family, as you can see here. And at last, so these are the references that I have used for doing these digital assignments. So thank you, sir.